Good day everyone, I am Lindsay Ketson and this is a video presentation in calculus. For today's objective is to draw the graph of a polar function and finding the area of the region bounded by the polar curve. First, let's talk a little bit about graphing polar equation. Say we have something like r equals to cosine theta. One way to plot this is to plug in points. Let's plug in multiples of 6 pi and see what we get. When theta is 0, cosine is 1. 2 is times 2 is 2. So 2, 0 is a point. Plugging in a 6 pi, we've got 2 times root 3 over 2 or root 3. We can estimate that this to the 10th place and plot that point as well. For a third pi, we've got 2 times 1 half or 1, and for half pi, we've got 0. So we've just constructed a semicircle here. We'll find that if we continue through until pi, we get the other half of the semicircle. And then the values just repeat from there. So this is a circle with a radius of 1, with its center at 1, 0. We can verify this by converting into rectangular form. We just multiply both sides by r, change r squared into x squared plus y squared, and r cosine theta into x, subtract 2x, and then we can complete the square with the x terms by adding 1 to both sides, giving us x minus 1 quantity squared plus y squared equals 1, which should be a more familiar version of the equation for this circle. When polar equations get more complicated, their graphs get more complex, producing all kinds of different shapes with loops and rose curves, which can be quite beautiful. So now let's move on in finding the area of the region bounded by a polar curve. Here's the example. Find the area enclosed by one loop of r equals sine 4 theta. So I'm going to try to come out with a decent little graph that I already know. That it's going to be 1 half, and I have to integrate sine of 4 theta. This is the function. I have to square, so there's the square d theta. Now, the only thing I really have to work for, at least in this example again, are the limits of integration. The way that it helps me find the graph of this thing. What I'll do is I like to figure out for what theta values does the radius equal 0. So to help me get a graph, I'm just plotting points. I like to solve this equation, so I want to know what values of theta I get a radius of 0. Well, if you think about it, sine of, let's see, 0 would equal to 0 normally. Well, what it says again is we would like the inside the 4 theta. I would like that to either equal 0 or pi or 2 pi or 3 pi, etc. When this happens, that's what I'm going to get sine of those corresponding angles, giving me a radius value of 0. And you can imagine dividing both sides by 4. This is going to happen at the angle theta equals 0. Pi over 4 to pi over 4, 3 pi over 4, and etc. So, what I'm going to do here is I'm just plotting points. So now I know at 0 pi over 4 to pi over 4, etc. I know that for these angles, that the radius is always going to be 0. So it tells me that when the angle of theta is 0, it says my radius value is 0. So let's think what happens next. I'm thinking about intervals in the, so the theta values between 0 and pi over 4, the angle pi over 4 is going to be this angle. So here's theta equals pi over 4. Again, the angle theta is equals 0. That would be the correspond to our x-axis. Notice as theta increases, our value that theta will increase sign for a little bit. Then start getting bigger and bigger and bigger. I think you can justify that pi over 8, we're going to be at its maximum distance away. So once we get out to an angle pi over 8, which is halfway between pi over 4 and the angle 0, it'll be at its maximum distance, and then as theta increases from pi over 8 to pi over 4, sine is going to start decreasing, and it gets pulled back into the value of 0. So basically, I'm finding my limits of integration by doing this. So once I get the limits of integration come from that, then we've got now our lower limit of integration. It's going to correspond to theta equals 0. Our upper limit of integration is going to correspond to theta equals pi over 4. And now I have to do is integrate this. So we're going to use one little identity here. Remember that there's an identity that it says sine squared of theta equals 1/2 1 minus cosine of 2 theta. So to integrate sine squared for theta, equivalently, I can write sine squared of 4 times theta. That's going to be 1/2 of 1 minus cosine. And notice it says whatever theta is on the left, you double it on the right. So we have 4 theta here. I'm going to get an 8 theta there. Okay, so this is the identity. I'm going to use on the sine squared of 4 theta part to kind of break it up. So when I integrate, I'm going to pull my original 1/2 out from there, out front. So there's 1/2 that just comes from that formula, and then when I use my trig identity on the sine squared for theta, I'm going to get all this stuff. I'm going to get 1/2 1 minus cosine of 8 theta d theta, and again we have to integrate this simply from 0 to the value of pi over 2. So now it's just tense integration. I'm going to multiply the 2 1/2 and get 1/4. If I integrate 1, I'm going to get theta. And the antiderivative of cosine 8 theta is going to be sine of 8 theta over 8. And you can justify that using a substitution. We have to evaluate this from 0 to pi over 4. So let's go ahead and do that real quick. Again, we're finding areas here. So you get better something positive out or something went wrong. And let's see it here. Okay, let's plug in everything in. We're going to have 1/4, plug in pi over 4. I have to subtract away the sine of 8 times pi over 4 again. That's all being divided by 8. There's my upper limit of integration. And then we'll have to subtract away the lower limit. So if I plug in 0, I'm just going to get 0. Notice on the inside, 8 times 0 will be, we know that sine of 0 is 0. So the lower limit just turns into zeros. So we're almost there. Pi over 4 is just chilling. Notice 8 pi over 4, that's 2 pi. So really we get sine of 2 pi divided by 8. But likewise, sine of 2 pi is just equal to 0. So if we multiply, it looks like to me that we get the value of pi over 60. So I hope that this video makes sense. that is the end of my presentation. Again, I am Binsi Kansan and thank you for listening.